In this section, we're going to be expanding on function algebra by talking about function composition. To help us understand what's happening, let's draw a picture to get started. So imagine we have two functions, f and g, and we're going to start with our function g, and we have the domain of g, and we're going to have the range of g. And then g is a rule that takes things from its domain to its range. Then we're going to have another function, f, with its domain. So we have the domain of f, and we're going to have the range of f. And f takes things from its domain to its range. The idea of function composition is instead of stopping here in the middle, we're going to go directly from the domain of g to the range of f. So this is f composed with g. Alright, so let's leave ourselves a little space because we're going to come back and write something else on this diagram in a little bit. So the first thing we need to talk about are some symbols that go along with this. So the symbol for composition is a circle centered on the line. And when we see this symbol, we can call it circle. So in symbols, we would write f circle g parentheses x, and this means that we are going to put the function g into the function f as an input. This is read as f circle g of x, or f composed with g of x. In symbols, f circle g of x means everywhere we see an x in f, we replace it. So we replace x with g of x. So we are literally evaluating a function at another function. So let's go ahead and take a look at our first example. So given that f of x is 1/2 x plus 4, and g of x is equal to 2x minus 8, we want to find g circle f of x and g circle f of -2. So when we have our function composition, it always means that we're going to be putting the second function into the first. So our g is 2x minus 8, and our f, which is going to be our second function, is 1/2 x plus 4. So when we have g circle f of x, that means we are going to put f into our function g. So it's g evaluated at our function f of x. So that means everywhere in our rule g where we see an x, we are going to replace that entire thing with f of x. So 1/2 x plus 4 take away 8. So that is our g circle f of x. And we need to simplify by distributing into our parentheses. So we have g circle f of x, and 2 times 1/2 is 1, so they're going to reduce out. That gives us x. 2 times 4 is 8, minus 8. So then finally, g circle f of x, the plus 8 and the minus 8, reduce out, add to 0, and we end up with x. So g circle f of x is equal to x. The second part says, in our new rule, g circle f, we want to replace our x with 2, or negative 2. So then we're going to get just negative 2. So g circle f of negative 2 is negative 2, because g circle f of x was just x. All right. So now it's your turn. Let's go ahead and take a look at your U-try. So in this one, we have f of x is 2x plus 1 and g of x is x minus 3. And we're asked to find f circle g of x and then f circle g of 3/4. So this time we have f circle g of x, which means we're putting the second function into the first function. So we're putting g into f. So everywhere in f where we see an x, we are going to replace it with g of x. And our g of x is the same as x minus 3. So once again, we open our parentheses by distributing. So we have f circle g of x is equal to 2x minus 6 plus 1, which gives us 2x minus 5. So f circle g of x is 2x take away 5, and then the next part is f circle g of 3/4. So f circle g evaluated at 3/4 means we replace our x with 3/4. So we go ahead and we have 2 times alpha y equals, we get our 3/4, take away 5, and we hit enter, and we get negative 7 over 2. So f circle g of 3/4 would give us negative 7/2. All right, moving on to our next example. We're going to be doing the same thing. So given that f of x is 5 over x minus 3, and g of x is 1 over x, we want to find f circle g, and then we want to find the domain of f circle g of x. So let's go back to our thing at the beginning and see if we can figure out how we're going to get the domain of f circle g. So function composition was we started in the domain of g and we're going to end up in the range of f. So g takes things from its domain to its range, and f takes things from its domain to its range. But for the composition to make sense, the range of g has to overlap with the domain of f. So what's going to happen is we may need to restrict the domain of g So its range is in the domain of F. So we may need to restrict the values that we can use in the domain of G so that we make sure that we're landing in the range of G in such a place that it also overlaps with the domain of F. Otherwise, the composition wouldn't make sense. So a way to help you visualize this is it's kind of like airports. If you want to fly from Phoenix to New York, most likely you're going to have to stop at some other airport, let's say in Atlanta in Georgia. But if you flew from Phoenix to, say, somewhere else like San Diego, but San Diego doesn't fly to New York, that's not going to be helpful. So if we're going to stop over somewhere, we need to make sure that where we're stopping actually goes to where we want. The composition represents the idea of a direct flight, which is better than having to stop somewhere. But that helps us visualize what the domain is going to be in this case. So now back to our problem. Let's find F circle G first. So F circle G of x is going to be F evaluated at G of x once again. So everywhere in F where I see an x, I'm going to replace it with G of x. So my G of x is 1 over x, so that's going to give me 5 over, and my x becomes G of x, which is 1 over x, take away 3. So now we have a compound fraction again, so let's multiply the top and the bottom by x, and when we do so, we get 5x, x times 1 over x is 1, and x times 3 gives me 3x. So then my F circle G of x is 5x all over 1 minus 3x. Now we want to find the domain. So in order to find this, if we look back at our diagram, the first thing we have to start with is we find the domain of G. So step 1 is we find the domain of G. So in our case, our G of x is 1 over x. So we're not allowed to divide by 0. So the domain is from negative infinity to 0, not including 0, and from 0 to infinity, because the only value that we can't put in here is 0, because 1 divided by 0 is undefined. So then the next thing we need to find for step 2 is we find the domain of F. So our F is 5 over x minus 3. So once again, we can't divide by 0, so this can't be 0. So x minus 3 is equal to 0. When we solve, plus 3, we get x equals 3. So x can't be 3. So our domain here is from negative infinity to 3, unioned with 3 to positive infinity. So remember, from our diagram, we may need to exclude or restrict the domain of G so that its range is in the domain of F. We just found a value in the domain of F that x can't be. So in our example, we know that x can't be 3. So that means we need to find anything in the domain of G that has output 3. So to resolve this, we are going to do the following. We're going to exclude any inputs from the domain of G that have an output not in the domain of F. So the only value that we know that's not in the domain of F is, we know that x can't be 3. So the output of G, so G of x was equal to 1 over x. This is our input. And 1 over x is our output. So we have to find any x values such that 1 over x can't be equal to, so our output can't be equal to 3. So we solve this equation by multiplying both sides by x. We get 1 equals 3x. We divide by 3, divide by 3, and that gives us x is the same as 1/3. So x equals 1/3 is not in the domain of F circle G. So then we exclude this value from the domain in step 1. So in step 1, we found the domain of G, which was -infinity to 0 unioned with 0 to infinity. So if I put that on the number line, our domain was everything but 0, so this was already excluded. And now this says we must also exclude this value. So then our domain would be from -infinity to 0, unioned with 0 to 1/3, unioned with 1/3 to positive infinity. So the 0 was excluded in step 1 when we found the domain of G, and then the remaining steps 2 and 3 were to find any other excluded values that we needed to find. Let's take a look at our next one. So given that f of x equals x squared minus 3 and g of x equals the square root of x plus 3, find F circle G and find the domain of F circle G. So F circle G of X means we're going to put G into F, because it's always we put the second function into the first. So that's going to be, we replace our X with the square root of x plus 3 squared minus 3, which is going to be x plus 3 minus 3, because the square and the square root are inverses and undo each other. So then the plus 3 minus 3 adds to 0, so once again we get just x. Alright, so then to remind us, our first step is we're going to find the domain of G. Well, we take our radicand and we make it greater than or equal to 0. So we minus 3, we minus 3, and we get x is greater than or equal to negative 3. So then on our number line, our domain would be from negative 3 all the way up to positive infinity. So then step 2 is we need to find the domain of f. Well, f is x squared minus 3. And there's no number that we can't square and take away 3 from, so this has domain all real numbers. Well, if this has domain all real numbers, that means that we can put anything in. So if we go back and look at our thing, well, if the domain of f is all real numbers, no matter what g gives us that's in its domain, it will automatically be a real number. So we don't need to do any additional restrictions. So 3, since the domain of f is all real numbers, we don't need to exclude any more values. So then the domain is just what we got in step 1. So it's still just going to be from negative 3 to positive infinity. So in mathematics, whenever we learn how to do something, we always need to learn how to undo it or do its inverse. So just to see what we had, we've been doing function composition. So when we do function composition, we're putting the second function into the first. So with composition, we did the following. We replace each x in f of x with g of x. Well, if we want to do the opposite thing, we're going to call it decomposition. First thing we're going to need to do, we replaced each x in f of x with g of x. So the first thing we need to do is identify g of x. And then 2, we're going to replace each g of x with x. All right. I guess to recover f of x. So here's a tip. G of x is the inside function. So we want to look for a function that is inside of another function. All right, so let's take a look at example number 4. So find f of x and g of x such that h of x equals f circle g of x if h of x is pi divided by 2x plus 5 cubed. So our tip said to look for something that's inside of something else. Well, in this example, we see that the 2x plus 5 is inside of the cubing function. So that would suggest that our g of x is equal to 2x plus 5. So that's our step 1. And then step 2, to recover f of x is this function, but we replace all of our g of x's with x. So we would have pi divided by, and the stuff that's highlighted in red would just become x cubed. So that would be the decomposition of those two functions. And we can check, because if I replace this x with 2x plus 5, I would indeed get the new function h. All right, let's try the next one. So find f and g such that h equals f circle g of x if h of x equals x plus 5 to the 7th plus 3 times x plus 5 cubed plus 1. So once again, we need to look for something that's inside of something else. And we'll notice we have an x plus 5 on the inside and an x plus 5 on the inside. So once again, we identify our inside function, or g of x, as x plus 5. Then, to find our outer function, or f of x, we replace all of our stuff that's highlighted in red, or all of our x plus 5s, with just x. So we would get x to the 7th plus 3x plus 1. And that would be our function decomposition for those two functions.